We'll record this as well, so if someone needs it later. I've chosen quadratics, which is topic 2 in your booklet. That doesn't matter which topic we start first. Only what matters is if it has any prerequisite. So if you remember, quadratics were equations looking like this: ax square plus bx plus c. Whenever you have such equation, we call it as expression. And if it looks like this, ax square plus bx plus c equals to something, it may be 0 or any constant, then it is an equation. The only difference is in expression, you factorize it, and in equation, you factorize and as well as find the values of x. We'll take an example. This is O levels, then we'll jump on to A levels. For example, x square plus 5x plus 6. If this would have been an expression and we are asked to factorize it, we can use middle term breaking or completing square or quadratic formula. So this is x square plus 2x plus 3x plus 6. Any disagreement in this thing? That these are the two factors. 2 plus 3 is 5. 2 into 3 is 6. We are getting the product as 6x square and the sum as 5x. Taking out common from the first two expressions, taking out common from the next two, simplifying it, x plus 3 times x plus 2. So this has been factorized. If the question would have been x square plus 5x plus 6, we will be having same steps till x plus 3, x plus 2, and if it is equal to 0, we'll have one additional step, which is x plus 3 equals to 0, x plus 2 equals to 0, and the values are x minus 3 and x minus 2. So this is the main difference between an expression and equation. For equation, you need to factorize and give the numerical value of the unknown. And in case of expression, only factors. This method was known as middle term breaking. Middle term breaking. Moving on to second method, other two are only used for finding the values, which is completing square and the third one would be quadratic formula. I'm starting with completing square, copying the same equation, which is x square plus 5x plus 6 is equals to 0. Can you hear me clearly?
Yeah, I can hear you clearly.
Okay. You can stop me anywhere where you feel like asking anything or something. Rather, coming back to the question again, you can stop me right away. So this is x square plus 5x plus 6 completing square. What we used to do was x squared plus 5x. Then we use coefficient of x, divide it with 2. Then we put a square on it. First step, coefficient of x. Second step, half of it. Third step, square of it. Fourth and final step is add and subtract. So we're adding 5 by 2 square and subtracting 5 by 2 square. So mathematically, it makes no change. Then we close these three. And what are we doing? We are using this a plus b whole square. This was equal to a square plus 2ab plus b square. We are reversing this equation. So reversing it, I'm copying x from here, positive sign, 5 by 2. Give it a second and see if you open this using the algebraic formula, will you get the previous equation? Like if we can open it to this, we can close this back to a plus b whole square mathematically, obeying the law of reversibility. Further simplifying, x plus 5 by 2 whole squared. I'm using calculator here. This is, or I'll just show all the working. 4 minus 25 plus 24, and this was all equal to 0. This turns out x plus 5 by 2 whole squared minus 1 by 4 equals to 0. Now the next step is to find x. So x plus 5 by 2 whole squared is equals to 1 by 4, squaring both sides, square root both sides. This is x plus 5 by 2 equals 1 by 2, and x plus 5 by 2 equals negative 1 by 2. So x is equals to 1 by 2 minus 5 by 2 is minus 2, and x is equals to negative 1 by 2 minus 5 by 2 is minus 3. If you can notice, x negative 2, negative 3, and previously it was the same, negative 2, negative 3. Whatever method you use, you get the same answers. This was middle term breaking O-levels, completing square O-levels. We will be using this completing square in A-level to a much greater extent. And the third form is quadratic formula, which was minus b plus minus square root b square minus 4ac over 2a. Copying the equation again, that was x square plus 5x plus 6 equals to 0. If I have to write a, b, and c, can someone tell me what is the value of a?
X.
General
No,
equation
the
was,
value of A is 1, right?
yeah, value of a is 1. General equation was ax square plus bx plus c. Whatever is with x square is a, with x is b, and the remaining constant is c. So a is 1, b is 5, and c is 6. Do not forget that you will be having your calculators with you while solving. So it doesn't really matter whatever the value is. The question is always easy for you. Minus 4, a is 1, c is 6, 2a. Simplifying it, this is minus 5 plus minus 5 squared is 25. 4 6 times is 24 by 2. So this is minus 5. Square root of 1 is 1 by 2. So 5 minus 5 minus 1 by 2. The other is minus 5 plus 1 by 2. Simplifying it, minus 3 minus 2. Any sort of disagreement in these values? Okay. So we used middle term breaking. Answer is minus 3 minus 2. Completing square form. Answer is minus 2 minus 3. Quadratic formula, minus 3 minus 2. All three times same answer. So from here we will lead towards our section of A levels, and we will need this thing, b square minus 4ac, known as discriminant. There's a lag. Discriminant, which is b square minus 4ac. So what now? What does discriminant have to do with all this? There are three things, which is b square minus 4ac is either less than 0, b squared minus 4ac is greater than 0, or the third one, b square minus 4ac equal to 0. So what actually happens is minus b plus minus square root b square minus 4ac over 2a. So it depends. When b square minus 4ac is less than 0, the values are not real. Roots. We use the word roots in A levels for this. Minus 3 and minus 2 were the roots of this equation. Or we can say minus 3 and minus 2 were the solution of this equation, but the word will be used as root. When b square minus 4ac is less than 0, roots are not real. When b square minus 4ac is greater than 0, roots are real and distinct. When b square minus 4ac equal to 0, roots are real and equal. We have to understand these things, these three in depth. It is 1/3 of topic 1. So when b square minus 4ac is less than 0, roots are not real. This means that the graph is not touching the horizontal axis. So there are no roots, like in simultaneous equations. B square minus 4ac, when it is greater than 0, the graph is intersecting the x-axis at two different points. So that is why we say roots are not real, because it is not intersecting, it is not touching, there is no solution. When it is greater than 0, it intersects at two different points. So roots are real. And when b square minus 4ac is equal to 0, it touches at one point. Equal to 0, it touches at one point. So roots are real and equal. Just a little example, you would have faced something like this. X plus 6 times x plus 6 is equals to 0. So both the answers are same. This was the case. This was the reason behind it, that it was just touching the curve at one point. Now, how will you remember this? Less than 0 or greater than 0 or equal to 0? Definitely one method is you memorize it, but that's rote learning. So the other is you understand it. The main formula was minus b plus minus square root b square minus 4ac over 2a. And we are discussing about b square minus 4ac. Just for our ease, if I can take the value of this remaining thing as, let me say, I'm taking a as half, or just ignore it, like denominator is 1. If I say I have 10 plus minus square root something, so when b square minus 4ac is less than 0, b square minus 4ac less than 0, that means negative. What happens when you use your calculator and put a negative value below the under root?
Yeah.
What happens when you use a negative value below under root?
You get a math error.
You get a math error. So having a math error, may I say there are no roots, there is no solution, there is no answer. So that's how you'll remember it, that having a negative value, that is b square minus 4ac less than 0, will give a math error. So there are no real roots and the graph will not touch the x-axis. Second example, if b square minus 4ac is greater than 0, like having any value below this, which is greater than 0 and positive, so 10 plus minus square root, let me suppose 4 for my ease. So we have a perfect square. This is 10 plus minus 2. Whenever there is a value, this was 4, so perfect square is 2. If it would have been 5 or 7 or anything else, we'll definitely get answers in decimals. But that would be 10 plus something and 10 minus something. So 10 minus something is this and 10 plus something is this. Whatever the answer would have been, we will get two different answers. Any doubts? And when we have b square minus 4ac equal to 0, so that is 10 plus minus b square minus 4ac, 10 plus minus 0. So when it is 0, answers are same. 10 plus 0 is 10, 10 minus 0 is again 10. So we have equal roots. So in case of greater than 0, it intersects at two different points. In case of equal to 0, it intersects at 1 point. Is this picture a little clear that b square minus 4ac, the use of discriminant, just having a look at it without solving, you can let anyone know that you will get two answers, a single answer or no answer at all. So let's try a question. How will you be getting these questions in exam? Before I move on, I would like to share another example to make things more clear. For example, I have an equation y is equals to x square plus 2x plus 5. This is a quadratic equation. And I have another equation which is y is equals to mx minus 7. This is quadratic. The second one is linear. So one will form a curve, the other will be a straight line. But the value of m is unknown, so we cannot really say that they will intersect or not unless until we are provided with more information. Consider this sketch. If I say that the curve will look like this, then may I say that the line, it has a y-intercept of -5 and gradient m which is unknown. So I'm assuming that -7 lies here, and whatever the gradient will be, it will be a straight line. If I say the value of m increases, if the value of m increases, will you accept this line that the line goes from green to black?
Which value increases?
Value of m, the value of gradient. The line becomes more steeper, the slope increases. In O levels, the general equation was y equals mx plus c. C was the y-intercept, m was the gradient. This intersecting point at y-axis is c, m is the gradient. Do you remember this?
Yes.
This is the prerequisite. If there is an issue, I will make you memorize it, remember it, or recall it.
Repeat the question you were asking before.
I was asking that if you remember the concept of gradient from O levels.
The original question that you were asking.
The original statement was when we increase the value of gradient, the line changes from green to black. And if we further increase the value of gradient, the line may result like this to red. Like increasing the gradient raises the line and increases the slope. Line 1, line 2, line 3. It means the gradient is increasing. From 3 to 1, the gradient is decreasing. Any doubts about this thing? That increasing the gradient means more slope.
Doubts?
Suppose you are going to a hill station. First, the roads were flat. Then it started climbing and there was a steep rise, then again horizontal. So you can say section 1, section 2, section 3. You can say the gradient was 0. Then the gradient started to rise. Let me say the gradient is 1. And then the gradient increased again. Let me say the gradient is 3. And again, when you reached at the top, it was horizontal. Gradient was again 0. So gradient is slope. Formula was y2 minus y1 over x2 minus x1. Rise over run. Do you remember this?
Yes.
We need to be very certain
So,
about two things. One is definitely if I ask you that square root of 100 is 10, the answer would be either you know it or you don't. Okay, there are few prerequisites which you must know. In case you don't know that, I'm your teacher, won't be blaming you. We can revise that. On the other hand, I'll be teaching and you won't getting it. The result will be wasting your time, or having said that the teacher was unable to convey the concept. Okay, if you do not remember anything because of any reason, that's not an issue. You can always let me know and we'll revise that first and then proceed to next topic. Okay. So coming
okay.
back to the main idea, we had an equation y is equals to x square plus 2x plus 5. And we suppose that this curve looks like this. Then a straight line. Because the value of m was unknown, so we cannot actually draw it. But just to discuss, we laid a line in green, then in black, then in red. And we said that if the gradient is increasing, the line is becoming more steeper. If it continues to increase, it may intersect the curve at different points. If we extend our graph, this will be something like this. This line may intersect it at two different points. So it depends what the gradient is. It will either not touch the graph, one case. It will either touch the graph at one point, second case. Increasing the gradient further may cut the graph at two different points. So it will depend on the statement of the question. The question is x square plus 2x plus 5 and y is equals to mx minus 7. If the question says find the value of m for which the line touches the graph, for which the line touches the curve. So this will be second. Find the value of m for which the line touches or is tangent to the curve. Tangent to the curve means it touches at one point. So using substitution, like we did in O levels, simultaneous equations, substitution, y is equals to y. This is x square plus 2x plus 5 is equals to mx minus 7. Y is equals to y. Rearrange the equation. X square plus 2x minus mx plus 5 plus 7 is equals to 0. This will be x square. Taking out x common is 2 minus m plus 12 is equals to 0. Now the question says that the graph and the line intersect at one point. If they intersect at one point, b square minus 4ac, what is it? Less than 0, greater than 0, or equal to 0?
You're right.
If it touches at one point and is a tangent, then it is equal to 0. Now we'll select the values of b, a, and c. B was coefficient of x square, which is 1. B was coefficient of x. B is coefficient of x, which is 2 minus m whole squared. A is coefficient of x square, which is 1. And c is the remaining constant, which is 12 is equals to 0. A square minus 2ab plus b square minus 48 equals to 0. M square minus 4m minus 44 is equals to 0. So we get a simple quadratic equation. Solving this will give you the values of m. I would like you to ask few questions. Anything which is creating confusion. Middle term breaking O levels, completing square A level, but we will be doing this to a greater extent. So that's not an issue if you've forgotten this. But this is a prerequisite. Middle term breaking and quadratic formula, where the equation has turned out to be a simple quadratic equation. Minus b plus minus square root b square minus 4ac over 2a. Just plug in the values and you'll get your solution. Minus b plus minus under root b square minus 4a c over 2a. So 4 plus minus. Can anyone solve this for me? My calculator isn't working.
$192 for the
Thank you. And square root of 192 is
13.85.
13.85. So we'll get these two values of m. When m is equal to these two values, it intersects the curve at one point only. So how would it look like when the value of m is positive? It looks like this. When the value of m is negative, the line would look like this. Other than this, it will either not touch the curve or intersect the curve at two different points. We'll have our next class tomorrow again at same time. And for the day, I will be expecting that you'll revise two things. One is completing square form, and the other is quadratic formula. Completing square form and quadratic formula. Just revise a little and we'll do it in detail. If you would like to ask any questions, you may ask.
I have a question.
Yes.
The equation is 4 plus minus 13.85 over 2, right?
Yeah.
Since it is above 0, shouldn't it intersect the graph on two separate points? Or
Okay, let's
am
find the
I
answer first. And you're confusing it with two things. These are values of m. Okay. These are
Oh,
values of m. The
oh,
actual
okay.
equations are the curve and the straight line. For these two values of m, let's solve this. This is 4 plus 13.85 divided by 2, that is 8.9. The other is 4 minus 13.85 divided by 2 is negative 4.9. Just to discuss, I'm taking it 9 and minus 5 for the time. So suppose 9, when the gradient is 9, this is your line. When the gradient is minus 5, this is your line. At these two values only, at these two values only, the line touches the curve at one point. If the value of gradient will be more than 9, just assume it is more than 9, the line will be more steeper and definitely it will intersect at 2 points. If the value is less than 9, assume this, it will not touch it. The question stated this, that it is a tangent, it touches. That is why we used v square minus 4ac equal to 0. But definitely the values would have been same, but this equality sign would change with more than or less than. So the expression also explains this, and the diagram explains this. Is the value is less than would mean the line is at a lower level. Line is less steep and it will not touch the curve. More than would mean line will raise and it will intersect at two different points. I'll also use a software known as GeoGebra. I'll show you these. Visualizing it can also increase the understanding. Suppose we have one equation, y equals x square plus 5. Can you see this?
Yes.
And we have a line. In this case, this is software, so I would have to give it a value. So as we used y is equals to mx minus 7, I'm giving it a value 2. So 2x minus 7. So 2x minus 7 would look like this. If I increase the gradient, that is the value of 2. If I increase that, 3x minus 7, it looks like this. If I can zoom out. So this. Are you getting the point? I'm increasing the gradient. 4x minus 7. What's happening? Increasing the gradient. It is coming closer to the curve, and at one particular value, it will just touch. Before that, these three cases are b square minus 4ac less than 0. One case would be it is touching the curve, and more than that, it will intersect at 2 points. So let's say 5x minus 7, I'm increasing it. 12x minus 7. So look at this, 12x minus 7 intersects it at two different points. When we will use b square minus 4ac, we will get one exact value. Is it clear? We can also use negative values, minus 2x, minus 7. Now compare these two lines. If you can see my cursor, this is negative 2, this is positive 2. So it reflects each other in either sides. And if we can type our main equation here, which was x square plus 2x plus 5. X square plus 2x plus 5. So this is x square plus 2x plus 5. And we had the other one y is equals to mx minus 7. And we are having value, one is 9, the other is minus 5. So when I use 9x minus 7, this is my answer. And when I use minus 5x minus 7, so this is the answer. So you can see that it touches the curve. So this is b square minus 4ac equal to 0. I think it's getting better or no? We're running out of time. It will end automatically. I'll continue it from here.